is Abdulaziz Alajlan, and this is Lab 1 for Physics 2211. And yeah, let's get started. In terms of content, I've got first of all the introduction and some a preview of what is going to come and what the results were, and then you got the fundamental principles and laws that we're going to go over, and then the analysis of the ball. You'll see a ping pong ball, the analysis of its motion, and then you got the code, and then the computational model, which is the glow script versus the ball's motion coming from the tracker, and then you got some critical questions that we will be answering. So you got the introduction, and the purpose of this lab is to validate Newton's second law by examining the motion of a moving object at a constant speed without changing the direction. Now we're gonna see that the analysis of the video and then the model that's been computed, and comparing them together would sort of validate the Newton's second law. And then our goal is to assess whether the observed motion aligns with the prediction. And we'll eventually find out that the lab results do confirm Newton's second law through the video analysis, showing that the object's motion aligns with predicted positions based on the physics principles. Now for Newton's second law, of motion states that the force acting on an object is equal to the mass of that object multiplied by its acceleration. This fundamental principle describes the relationship between the motion of an object and the external forces acting upon it. Now if we go to the analysis of the ball, first of all, we know that the ball is the is the system, and me pushing it was the surrounding forces. So when I started pushing it, you can see on the table I have 2 points marked down. They're exactly 50 centimeters apart, which is what I also inputted in the tracker. And yeah, it was exactly 50 centimeters, and I pushed it up into the point that it started tracking, which I let go, so I made sure there was an acting force upon it. You have that initial position at x equals 0.000572, and then the time of 1.67 seconds. Now here is the code. I changed the position to what I got, and then the time to what I also got, and then just inputted it into the while loop as well. And yeah, I ran it. Couple of times it didn't work out because I forgot to change the sign on the position and on the velocity, but eventually gave me this result. Now it seemed a little too far apart for it to be as accurate as I wanted it to be, but I think that makes sense, since the actual tracker could have been off. It could have been me, human error. It could have been the tool error. It could have been just the fact that real life and exact physics simulations are not supposed to be identical. There are more factors. There was friction involved, the AC was on, thus there was air blowing against the ball, and so it's not completely 100% accurate. And I feel like the fact that there is error between the two graphs shows that it's more realistic. And yeah, so now we got the critical questions. Now for the what if, realistically speaking, if you flip the axis, it wouldn't actually change the physics. It would only flip the direction. So axis orientation impact, if the axes are flipped, the results may change. So the actual result is probably going to change, but the physics itself is the same. And flipping positive x to negative x only alters the direction representation. So it doesn't actually change the physics itself, merely the direction of the goal or the object. And then what does it mean for the pushes and pulls? Setting it to 0 just implies equilibrium. So setting net force to 0 implies equilibrium. The numbers of pushes and pulls adding up to 0 depends on their magnitudes and direction. So it's both the magnitude and the direction, and eventually what's going to happen is that they're going to achieve a balanced system. Now I did want to go over the glow script or the tracker just to show you a preview of the video. And yeah, this is it adding up. Now again, I might have not checked it correctly, since it's adding up multiple frames in what I would say shouldn't happen. So you got, for example, 5, 6, and 7 are way closer together than the other points, which I think is what skewed the data a little bit. But yeah, and you can even see here in the velocity, it's not consistent, which means that the push itself or the tracking itself is probably not accurate, since the velocity would be consistent, since the force would be 0 acting upon it. So I think that's what caused the error to occur with with the system or the graph, and why it's diverging. It's not exactly the same.